introducing Jean-Sébastien Bevilacqua, close, I'm sorry, who has joined us from a long way away. He's a Python guy, French guy, and has done quite a bit of hacking in the 3D space. Please join me in welcoming him.
Hi, okay, it's working? Okay. So, maybe, okay. Do you hear me? Yes? Okay. So, welcome everyone. I'm glad to be here with you today. So, if I give this talk, it's because I truly believe in CFFI to improve maintainability and robustness of Python extension. I want to share with you my experience in order to convince you to give a try to CFFI next time you need to write a Python extension. Okay. So, like you can hear from my accent, I'm French, and I come from Paris after one full day in plane. This is not the real time, you can add 3 hours. So it's very long, but it allows me to discover your magnificent country and you, Australian people. So by the way, you are very welcoming. Thank you. Who am I? So I'm Jean-Sébastien Bevilacqua. I write free software every day, and I'm a fan of open source ecosystem and philosophy. So you can find a big part of my contribution on GitHub. Moreover, I work at Linagora. It's a French company that promotes free software, and it's this company which encouraged me to give this talk. So if you need support for free software, just contact us. We'll be happy to help. So first, why do we need Python extension? I'm going to tell you my use case. So approximately 1 year ago, the new Vulkan API was released. Vulkan is a new graphic API that will replace OpenGL in the near future. I don't know if do you know Vulkan? Yes? No? Someone? Okay. So it's a very low-level graphic API. You can create AAA games with it, and it's cross-compatible with Windows, Linux, and Android. Nowadays, several Steam games use Vulkan. So 1 year ago, back at this time, I was enjoying OpenGL development, and with Vulkan, I saw an opportunity to improve my 3D and low-level knowledge. And of course, Python was my language of choice. We all know why. But there was no binding between Python and Vulkan. So you should use a language like C to use Vulkan, no Python. But as you may know, Vulkan is a low-level API, and in order to use it, you have to call low-level functions like dlopen and dlsim. So I decided to write my Vulkan binding for Python directly in C with the CPython C API at first. As a side note, you should know that Python extension can be used to improve performance, but it was not my use case. So sadly, with C language, you can have system errors like segmentation faults. And moreover, with Python, it can be very hard to track a segmentation fault. Also, you use Valgrind. It can help you, but it's still a difficult task that you won't enjoy, I promise. So to write a Python extension in C, you have to make use of the CPython API. It allows you to create modules, add functions, and classes in it. After reading the good CPython API, I started my C extension. So it was clear and I felt self-confident, but it's still C. So we have to fight against malloc and free like usual. But because it's too easy, CPython API adds the reference counting and the cumbersome API. I almost give up several times due to the amount of work. We are going to see existing solutions to resolve complexity of C extension. But before that, let's see ABI and API mode. Because from now, I will often use ABI, API words, so I need to explain clearly what I mean by these terms. API means Application Programming Interface, and ABI, Application Binary Interface. So the API mode, it's what humans use. You call a function, you need to know the name of the function and the argument to pass. So as a programming interface, it's all expressed in source code. The ABI is very similar, think of it as a compiled version of the API. To be clear, when you write the program, you use the human API. Then, when your program is compiled, computer will access the API of the library. Maybe you wonder the goal of API mode from a human point of view. We could just stick with the API. Accessing a library with API mode allows you to dynamically link at runtime, and thus can be used with an interpreted language like Python, without compilation. Also, API mode can be interesting to use. You have to explicitly describe the binary interface, like you will see after with C-types. So let's see the existing solution to easily write a Python extension. So like I said just before, you can do it with the CPython API, but it's a difficult task. The first one is Cython. Cython uses an interesting approach. It can execute directly your Python code, and you can add new syntaxes elements by iteration. It's very good, but when you start to add custom Cython syntax, like here, your Python code is no more Python, and so you lose portability, and Cython becomes a required dependency. You should take that into account before using it. Such a high dependency can be dangerous sometimes. Moreover, the first goal of Cython is to improve performance of Python, not to write a wrapper. Cython can be compiled, and thus supports ABI and API mode. That's a good point. Another solution that everyone knows is C-types. The only advantages of C-types is because it's a built-in, so it's a good point, because you can be sure C-types is always available. With C-types, you don't need compilation. It works on the ABI mode only. So you dynamically link at runtime to the library. So here an example of C-types. Like you can see on the screen, to use C-types, you need to learn a new API, the C-types API. You have to translate your C header to the C-types API. In this example, I declare, I forgot I have the same screen here, better to look here. So in this example, I declare a print struct and get back the vector size function from the library. It's error-prone and cumbersome. If you wrap a very big library, like Vulkan, it will be painful and it could lead to segmentation fault because you can have ABI mismatch. Now the lights. 7 years ago, two smart people, Armin Rigo and Maciej Fidzierowski, created CFFI. Maybe you know this name. Because they authored PyPy 2, so it's not a piece of cake. For information, PyPy is an alternative interpreter with a JIT. A JIT is a just-in-time compiler. So at first, CFFI was an alternative to C-types. It was working only on the API mode. Later, the API mode was added and revolutionized Python ecosystem, extension ecosystem. Before CFFI, to create an API mode extension for Python API, you had to use the CPython C API, or Cython, which only work with CPython. Now, with CFFI, extensions are working with CPython 2, 3, and PyPy without changing one line of your code. Now you understand ABI and API mode, I can show you how it works with CFFI. But let's introduce another concept of CFFI. This one is a lot simpler than ABI and API mode. The first is the inline mode. When you use the inline mode, everything is set up every time you import your Python code. In the out-of-line mode, you have a separate step of preparation and possibly compilation that produces a module which your main program can then import. Of course, inline mode is available only for ABI mode, since API mode always requires compilation. Okay. So this first example shows how to work with ABI and inline mode. It's a very classic example. This is the first feature supported by CFFI, and it's exactly what C-types is done for. So you can compare it with C-types. Like you can see, with CFFI, you just pass the C header to CDEF and open your library with DLOpen. That's all. Here, I let CFFI know the dlopen function by passing, the printf function by passing it to the cdef function. Next, I create a char argument, and I can pass it to the printf function. So it's just magic. CFFI syntax is clean and intuitive. If you run this example on your computer, you will get this result. It works very well. I print with the C printf function, not the Python print function. It makes a big difference. You can use all the entire C namespace with this demo. I usually do this demo in live, but last time it was at EuroPython and my terminal died during the talk, so I don't take the risk. But CFFI goes one step further with its API mode. This time we are going to use the API mode with the pwd library. Syntax still similar, but you can notice a difference. We pass C code to CFFI with setSource function. In the source, we just include pwd and types. In the cdef, we don't need to add all pwd functions, just the one we want to use. So here we use only 2 functions, and we don't need all fields of passwd struct. Finally, you just ask CFFI to compile your module. Okay, it's pretty clear. When you run this script, it compiles your module. It's just a Python script, and CFFI handles the compilation part for us. Compilation is fully cross-platform thanks to CFFI, so it works on Windows, Linux, Mac, I think. I didn't try. Like you can see, CFFI does the compilation in 3 steps. First, it generates a C file containing the source code and the CFFI Blackmagic C code. It compiles this file into an object file. And finally, it generates the Python module. So the Python module is a demo2.cpython, etc. With this mod, your Python extension is robust, fast, and easy to maintain. With this API mod, you can't have segmentation fault due to a mismatching API. You can have a segmentation fault if your code is not well working, but it's not due to a mismatching ABI. Okay, let's try it now. Do like it's a demo. Huh? It's not, but pretend it is. Okay, on the top you can see the content of demo2 run file and the result on the bottom. Like you can see, we get root if we ask for the PID 0, and we get 1000 if we ask for my PID. So like you can see, it's very easy and intuitive to use. The lib is contain all the wrapped library. So it's fully work, and it's a real compiled CPython extension. It's nice. Now, the interesting part. So I'm currently building a 3D engine with Python and the new Vulkan graphic API. Like I said to you, I created a Vulkan wrapper directly in C. But if I'm here today, it's thanks to Armin Rigaud. When I show him my Vulkan wrapper on IRC, it tells me you could have used CFFI. Of course, he wrote it. He then explained me advantages of CFFI. It took no more to meet the new challenge, write a Vulkan wrapper directly with CFFI. So was I ready to lose months of work? It's a hard decision, but I definitely made the right choice. I'm going to show you why. So, like all engineers, we love statistics. Vulkan API is very huge. 100 of functions, 100 of structs, 100 of constants. More than 5,000 lines of code for the C header. Wrapping all this API in plain C is madness, as you can see with this number. It's my first C wrapper. More than 60,000 lines for the generated C file. I'm crazy enough to have done it. Whereas, with CFFI, it's only simple and clean Python code. To give you an idea about time, it took me 1 month and a half for the C version and only 2 weeks with CFFI. This time is only on my spare time, so I think it would have taken only 1 week at full time with CFFI, very fast. When I got an open issue on GitHub, I can fix it in 1 hour usually, because it's just Python code. There is no C involved. And the C version was too difficult to maintain. So how this wrapper works? In both cases, I use a generator. Kronos Group did a very good job with Vulkan, because Kronos is behind Vulkan. All is open source, and you can contribute easily on GitHub. It provides an XML file that describes the API. So my generator takes this XML file as input and generates the Vulkan wrapper. By doing a generator, I can update the wrapper in 2 minutes when a new version of the API is released. So basically, here are the steps. First, I load and parse XML definition of the Vulkan API, because there is an XML file. Then I generate the data model. Next, I generate the Python module with a Jinja2 template. I think you know Jinja2 template engine. So, in detail now. Parsing, like I said, parsing is done with XML2Dict package. It's a good way to parse an XML file without IDH. It transforms your XML file into a hierarchical Python dictionary. So now that we have a good data model easy to parse, we can pass it to the Jinja2 template. And that's where the two modules differ between the C version and CFFI version. So what you see here is the folder structure of the C extension. For the C extension, there are too much things involved. So to keep the code maintainable, I had to split it up. Line of code is a good indicator here, but what is more important is the complexity of the code. Like you can see, it's pretty huge. Moreover, with C code, you have to manage memory yourself, and this is very error-prone. Now with CFFI, okay, I think it's clear. Despite of its looks, what you see on screen means a lot. With CFFI, I did not need to think about architecture. It was obvious, all in one file. So one more point for CFFI. You don't have to trust my words when I say CFFI is better. Let's see it in action, and you will understand. So constant. Constant, it is the easier part, and both cases are simple. In C, we just use the C Python API to add constant. But we have to take care about variable type. Like you see, for int, you have a special macro. With CFFI, it's just Python, and it's a dynamically typed variable. Only with constant, you don't go far away. So next step is to create binding for structs. But there is no struct concept in Python, so you can use classes, which is similar. With CPython C API, you have to handle the new, del, init, and get for each member. You have to use malloc to allocate memory for your object. In del, you must free your object. In init, you have to pass each parameter with CPython util functions. And in get, you have to convert your C struct to a Python object. So I can assure you, it takes me a lot of time to figure out how to do it properly. Code is so long that I can't show you an example on screen, but you can go on my GitHub if you want to see. With CFFI now, it's 40 lines. CFFI handles for us object allocation and deletion. I just used plain Python to handle all struct initialization in a generic way. I repeat to be sure you understand, this generic new function works for all structs of Vulkan. With CPython API, the step I showed you just before must be done for each struct. And there are hundreds of structs. So when you realize these benefits, you just fall in love with CFFI. What I showed you until here with the Vulkan wrapper is the ABI mode. So let's try the fast and robust API mode now. We are going to wrap a C library with the API out-of-line mode. This mode is robust and fast, but you need compilation. Maybe you know ShaderC. I don't know. So we are going to wrap ShaderC library. ShaderC is a free software done by Google guys, but not directly related to Google, and gives you the ability to compile GLSL language to SPIR-V binary. GLSL and SPIR-V formats are used to create program for your graphic card. So you take your GLSL code, you convert it with shadrc in SPIRV, and you put this SPIRV code in the graphic card to execute program. So it's very, very low level. But this software is very known among the graphic developer. And there is no Python. There is no Python wrapper. No, there is one. So when I do a CFFI wrapper, I usually create a folder dedicated to CFFI named CFFI build, and I recommend you to do so to keep a clean separation of concerns. So shadrc.h contains shadrc function signatures and structs. We just copy-paste the header provided by Google, and CFFI handles it. PyShadrc build is used to generate the Python extension. Next, we have the PyShadrc folder containing our wrapper, and finally, we'll take a look at the setup file with a special CFFI feature. So, like you see, we first read content of the shadrc header. Here, this is the script for building the wrapper. So, we first read content of shadrc header and pass it to the cdef function. That's all for the definition. 3 lines, and CFFI knows how to handle this library. It's beautiful. Sometimes you need to rework your header, but this time the header is clean, so you don't need to rework it, to refactor it. Now, with these few lines, we tell CFFI to compile the source with statically linked library shadrc combined, and to name the extension PyShadrc. And okay. So shadrc combined is a static library that we have to compile before running this CFFI part. I don't show you how because it's not directly related to CFFI. You can look on GitHub if you are interested in. So like you can see, there is no C code involved. We just tell CFFI to open a Python portal to the shadrc library. Here again, it looks like magic. But currently, our extension is ready, but we remain dependent of CFFI. For example, if you want to pass a pointer to a function, you have to use CFFI. When using your wrapper, your users should not need to know CFFI. It's just a dependency. So we are going to write a small Python code especially for that. The code is located in PyShadrc init and is loaded automatically when you import your module. So first, this is just Python code. The wrapper is handled by CFFI. Now we take the wrapper, the lib object, and we use it to make a proper Python API. So we first load our extension, PyShadrc, which contain IFFI and lib modules. Lib contain all functions and structs related to our library, defined in the C header. We need IFFI too to interface with our library. Let's examine the compile into SPIRV function. Remember, the shadrc library allows you to compile GLSL to SPIRV. So all functions defined in our extension can be accessed through lib objects. If you take a look at the compile line, we can pass pure Python types like int or string, and CFFI converts it for us. Clean and intuitive. Like you can see, note that with Python 3, string must be byte. I just put a B before the main. So shadrc returns a pointer to us. We have to tell CFFI to convert it to a byte Python object, because in Python there is no pointer. We can use byte. So we first get back the pointer and the length, but we can't directly copy the data to a byte in Python because byte type is immutable. So we have to copy data into a byte array and pass it to our bytes object. Take a look at the IFFI.memMove function. It's similar to the memcopy C function, but directly in Python. So I'm doing memory manipulation directly in Python. In bonus, CFFI provides the setup tools extension. You just add the entry CFFI modules, and your extension will be built by setup tools. Now we can enjoy the result. Let's play a simple game using Vulkan. wrapper and PyShader wrapper, the two wrappers we saw. So this simple game is written fully with Python and make use of the new shiny Vulkan API. It's a very simple, huh? It's not very... So just Python and Vulkan, no C code. Yep. Okay, nice game. But now you can do AAA game, but it's your turn to work now. So I hope that, like me, you enjoyed this talk. If one day you need to use a C library or to improve performance of your code, think about CFFI. Thank you for your attention, and have a nice day.
We do have a few minutes for questions, so if you've got one, put your hand up.
If you use the Setup Tools extension, does somebody installing your application need to have a compiler installed?
Yes.
And if
you use the API mod, you need a compiler.
Right.
But with the API mod, you don't need.
Okay. Would there be any way to pre-compile it and put it into a Python wheel?
I think it should work with the wheel, I think.
You can have that buzzword.
Yes.
What happens if you don't delete the Python object that is representing the C object? Will it automatically be freed when it gets garbage collected? And if so, is there a way to attach a C finalizer to an object? So you just say, when you go out of scope, please clean up this resource using this C function.
So yes, CFFI, if there is no reference to a C object, CFFI destroy it.
I have a question. How does it work with other languages? So if you're wanting to wrap something else, which is a compiled language like Rust or Go or something like that.
There is on internet you can find an example with Rust. You
So
can
it works fine.
it's just exporting an API. You can export your Rust header and you can use it with CFFI.
Using a Rust header, or you have to rewrite a C header?
I saw an example on a blog. I don't know who is the person, but it's just Rust.
Cool.
So maybe you need a C header because CFFI don't know Rust. So yes, you always need C header.
Cool. Any more questions? All right, please join me in thanking the speaker.
Thank you.
We have a cup. That's cool. Thanks very much. And we're back in at 2:15.